I'm going to give it over to Walter to let you tell him let him tell you a little bit about himself and about the talk coming up. You've got about less than 5 minutes, Walter.
Oh, well, I'll be brief. Well, I'm Walter Bright, of course, and I'm the head of the D Language Foundation, and been working on D for 20 years now. Seems like a long time. My upcoming talk is about reducing memory safety problems in D by introducing a straightforward ownership and borrowing system. And I'll be covering that. And there's been several questions about it, and I've deferred them all to wait and watch the video, and then I will answer the questions about it during or after this video. This is a new experience for me doing a live streaming like this, so we'll see how it goes. I hope you can all hear me clearly.
Well, I hear you fine. So what's the key point of this talk that you want people to take away?
The key point is you can get memory safety with data flow analysis by not needing to design a whole new language. You can use it as an addition to the existing language with familiar syntax. And there's no new syntax at all for this. It's just adding a simple keyword to it, and you can get an ownership borrowing system. So I'm pretty excited about it. I think it's pretty cool. Some people are skeptical that this will work. Well, I hope to be convincing, or at least hope that y'all will be willing to give it a try and see how well it works. It's always risky coming up with a new feature like this, something that hasn't been done before, and we'll just have to see how it works out. We can only find out by actually trying it out and seeing how it works.
Well, you talked about data flow analysis, and you actually took a course on data flow analysis back in the 80s, right?
Yes, I took the Stanford summer compiler course in the early 80s. It was 2 weeks long. 1 week was parsing and things like that at the front end of a compiler, and the second week was the back end. And one of the things they taught there was the math behind data flow analysis. So for me, it was like magic, how data flow analysis could do all the things I was wondering how compilers could do. And it was an introductory course, really. I mean, how much can you teach in 2 weeks? But it kind of proved foundational. And the data flow analysis covered in it is not the data flow analysis I'm using in this, but from what I learned from doing that, I could invent the data flow analysis that'll work for the tracking pointers.
So Walter, this has got to be like the first talk for which you've ever had a soundtrack, right?
That's right. First attempt really at video production. So it is a little basic.
Oh, it's just fine. It's informative. So when you were making it, you've done a lot of uh, presentations in your life. I don't know how many, but I know you've done several. So you have a pretty good feel for how long they take, but you were surprised that this one went rather quickly, right?
Yeah, I have a lot of slides, and I expected it to take over an hour, but I must talk fast or something. Or when I do things live, I do a lot of interaction with the audience, which is not happening here. And so it went rather quickly.
Well, something to keep in mind for DConf Online 2021, yeah?
Yeah, that's right.
So you're still you're very confident about the garbage collector as a good way to prevent memory corruption, and you were not always of that mind, right? You were a convert after you worked on a Java compiler, correct?
Yeah, I learned about garbage collectors mainly by implementing a Java compiler back in the mid '90s for Symantec. So in doing that, I thought garbage collectors were the future, but and maybe they are the future for a lot of programming, but still there's a vast need for explicit memory allocation, and explicit memory allocation has memory safety problems. So adding an ownership borrowing system is a way to deal with trying to avoid the usual problems you get with manual memory allocation.
And you implemented the GC from a book originally for Java, for the compiler you built, right? Or was that the JavaScript
Yeah,
compiler?
no, oh, I implemented the garbage collector from a book.
Well, I mean, you read a book to learn about it.
Yeah, it's the classic book, Garbage Collection, the blue book. I don't have the exact name of it in the top of my head, but it's kind of covers all the basic techniques for doing garbage collection. Was immensely useful for me to learn how garbage collector worked and to implement one. Of course, a lot of people have criticized the D's built-in garbage collector, that it's kind of old-fashioned and primitive, and well, that's actually true. Garbage collection technologies have increased dramatically in power over the years, and the one I implemented is a conservative mark sweep garbage collector, and it's fairly simple and straightforward. The best thing about it is it works, and it works reliably, and it works nicely.
And the GC that you originally implemented for D was based on a JavaScript GC you had implemented?
Uh, I had some dreams of making a competitive JavaScript compiler interpreter back around 2000, and with the idea that JavaScript was going to become the foundation of internet web pages, and that the world needed a fast one. And I implemented one called DMD script, or sometimes just Dscript, and it was about 20 times faster than JavaScript compilers of the day, right around that time. But people weren't too interested in it, so I moved on to D. But I did bring along with me to D what I'd learned implementing the garbage collector for the JavaScript interpreter. And since then, JavaScript interpreters have gotten enormously better and faster, because I was right about it becoming foundational for the internet. I was just kind of a little too early in the I was kind of ahead of the curve with that, and it didn't work out. So all my efforts then went into D, and so you can still use the JavaScript compiler. I converted it to run in D, and you can download it, and it did make a fine extension language if you're like building an editor or an IDE or something like that. You can have a JavaScript. You can use JavaScript as its built-in extension language. And I think JavaScript is an ideal language for using as a built-in extension language for any kind of interactive tool you might be developing, like an editor or an IDE.
And what do you say to people who are coming to D and the first thing they reach for is better C because it doesn't have GC, or they reach for the no GC attribute?
Well, the cool thing about D as better C is it doesn't require anything but the C standard library. So you can use it to write really small applications. It's easy to write an application that is just a few K in size with it. It doesn't use any more than an equivalent C program doing the same thing. So if you're tired of C's restrictions and safety problems, and especially if you're tired of the preprocessor and the lack of imports and templates and other modern features, D is a better C is a way that you can quickly get up to speed with D as better C, because it's almost identical to C. And as you get comfortable with it, you can start using the more advanced features of it. The ownership borrowing system is a part of D as better C. So there's one example where you can reap the benefits of a modern language while still fitting into the same footprint that a C program does with the same advantages that you have with C. You can manipulate things down to the middle, or you can use the advanced stuff, and you only, as they say, pay for what you use. Although you can't use the garbage collector with D as better C, because that would require the D runtime, and the D runtime is not part of D as better C. So the @live or the ownership borrowing system would indeed be a good fit for D as better C. You can develop device drivers with it and other low-level stuff.
Did this come, this idea come from your belief, like you expressed at DConf 2017, that memory safety is going to kill C?
Yes, it's all very related to that. I'm not sure when I started working on the ownership borrowing system, but I've predicted for a long time that generally once programs exceed a certain size, writing them in C is just impractical to make them memory safe. And these days, it's just too expensive to release a program with memory safety problems out, and languages will be required and expected to provide memory safety features, and C just does not provide any memory safety features. Like D is a better C, you'll have a lot of memory safety features in it, and that's just either D as better C or some other language are just simply going to be required if you're going to be releasing a professional quality product. Of course, C is still going strong, but I think that that's going to fade away over time, and people will move to memory safe alternatives. Obviously, D is not the only language in that space with memory safety as an option, but I do think it's one of the easiest ones to use and to get into doing memory safety with. Of course, experience will prove me right or wrong about that.
Well, I'll be interested to see how everything pans out. I think the language is going in different directions than I think anyone imagined in the past, for sure. And I think it's got a unique mix of features, and building on them like this makes it even more unique. I mean, it's as time goes by, it's less and less like C++ and C, I guess, is what I want to say.
Well, I expect C++ to become more and more like D, and it already has been.
Yeah, that's true. Yeah.
I think that I think for a long time people thought that you couldn't do this kind of data flow analysis in a low-level language or a low-level capable language, and I'm kind of, including me, I thought it was impractical to do it. Well, I don't think that way anymore. I think it's very practical, and the data flow analysis is a wonderful tool to tracking pointers and diagnosing memory safety errors with that.
There's a question in the live chat for your video. It says, it would seem you could keep the pointer alive using the temporary clone into the function, or does that cut it off as well?
I think maybe you're talking about borrowing.
Your answer was both the borrowed and the original can't be live at the same time.
That's right.
Can you expand on that?
Well, the whole point of the ownership borrowing system is you can't have two live pointers to the same piece of memory. So if you copy the value into a temporary, then you can't use the original while the temporary is still live. And data flow analysis is used to track which version or which copy of the pointer is live. And you can't have and make sure that there's no overlapping of liveness between the borrowed and the original pointer.
And do you have a question from Dennis Corporal on your talk? So can a live function call an impure function like printf?
Yeah, the short answer is yes. From your live functions, you can call any other functions in your D program. However, as the presentation goes into a little later, those other functions are going to have to adhere to the at live rules, or although it can call it, is not going to work. Only the at live functions are checked.
Can you borrow multiple subslices of the same slice mutably?
Yes, but only one at a time. Live errors are purely compile time creatures. It's purely, it's statically evaluated all at compile time, so there's no need for runtime throwing of any errors on that.
Okay, so the question was, providing that the code was purely linear, then the borrowed pointer could be usable in a function, but probably throw the error if both were on separate operations, separate cores. A? Okay. Question on the talk chat, what error handling mechanism will replace exceptions?
That is yet to be determined. There have been several ideas. One is to use, probably the most promising is one that where you have option types returned, which is basically a union that can either be an error code or the return value to a function.
So,
So I have not spent a lot of time working on that yet, but something like that will probably wind up being necessary with this. Or you can just use the traditional C method of returning error codes.
okay, we've got two questions here in the live stream chat, Walter. One of them is how will we be able, I guess, to introspect the pointer types like it is borrowed or owned? I guess he's wanting to know, can you determine if a pointer is borrowed or owned through introspection?
Currently, there is no scheme for introspection of the liveness of a variable. Frankly, I never thought about that.
The second question was, can live be inferred for auto template functions like safe?
Currently, inferring live would require doing the data flow analysis in it, and that is currently not done. You're going to have to explicitly mark them as at live or not. Of course, maybe in the future we can see about inferring it, but the current plan is it's not inferred. If you mark it as live, it's going to be live. And if you don't, it's not going to be. It's not going to be checked. The doing data flow analysis is expensive for compile times, and doing inference would require the data flow analysis, which would slow down your compilation significantly. I don't really know by how much. The current implementation of @live is not optimized for speed. I know there are a number of opportunities in it to make it faster, but I didn't worry about that. I was just trying to get it to work in the current prototype version. I know
Okay.
with the data flow analysis I've done with optimization, I spent considerable time making it faster after I got it to work. So there's probably a fair amount of opportunity for that in the code or in the implementation.
Okay, next question here. Any chance we'll see enhanced or built-in support for some types, possibly with auto conversion or extract value or return idioms to allow for non-exception based error handling?
Oh, that is a great question. We're going to make it work one way or another, and I don't know how yet because I haven't spent a lot of time thinking about it. There have been some proposals for option types in C++, and those look pretty interesting as one way to do it. But I'll figure it out. But that's kind of in the future. Right now, I'm just trying to get the ownership borrowing system to work.
Okay, next question. I find that I occasionally cast or use rebindable to achieve const ref to mutable or mutable ref to const. Would data flow analysis or static analysis benefit if these were better supported by the language?
That is a great question, and I don't have a good answer for that. You can't cheat on the ownership borrowing system, though. It's going to do data flow analysis, and if it works, it's going to pass, and if it doesn't work, it's not going to pass. The whole point of it is that you cannot cheat while you're inside a net live function. If you're gonna cheat or try some schemes to have two live pointers to the same thing at the same time, you're gonna have to go outside of @live to do that. So I'm not sure. You may not even need these constructs. if you're using at live functions, because the at live function will provide the enforcement for that for you. You don't have to build a wrapper to do it.
Okay, next question. Could data flow analysis be cached?
I'm not sure what you mean by that. You mean from one compilation to the next compilation?
Yeah, I think that's what he means. Per, could you expand on that, please? And we can come back to that. Steve has a question here. Is it true that live doesn't really affect the API of a function? It just affects the function that is tagged?
That is correct. It only affects the internals of the function that is tagged. At live functions can call at safe functions or trusted functions or system functions. So it is an orthogonal feature to the system / trusted / safe system in D. But if you are calling other functions with it, you're expected to adhere to the rules, at least as far as the interface to that other function goes. What you do inside that function, of course, is no concern of the ownership borrowing function. It's like calling an unsafe function, and that's what it'll be treated as.
Okay, back to that cached question. He says yes. He's talking about between compilations. Can you cache data flow analysis between compilations?
No, and there are no plans to do so, mainly because it's very tricky to prove that there's not some subtle change in things. Back when I did data flow analysis for optimization, a common source of problems was attempting to, well, I made this change. I only need to repeat the data flow analysis over here and not doing a thorough job of it. And so subtle bugs would creep into the data flow analysis. So how I've dealt with that issue with my implementations of data flow analysis is whenever the underlying data set changes, I redo the data flow analysis. And that may be extra work. It probably is extra work, but it's resulted in only a small number of, or a far reduced number of bugs and problems with the data flow analysis, because do not try to patch it. Do not try to cache it. If anything changes, just throw it away and recalculate it. So I'm doing the same thing with that live. Any changes, you just throw away and recalculate it. And if it's recompiling the module, well, it recompiles the module, including any data flow analysis needed on it. So no, it is not caching. One problem with caching, and this has been talked a lot about for template instantiations, one big problem is the memory and execution speed you save is lost by having to write the cache data out into a file in some format and then look it up and read it back in again. It's pretty expensive to do file I/O, and it's hard to see that it would actually be faster caching it.
There's another question for you here, Walter. Have you considered implementing the at-live rules in terms of type qualifier like const or immutable so that non-at-live functions like at safe could respect the rules?
That is a great question. Not really sure how to do that and do the data flow analysis is the first thing. And the second thing, that makes the checking very fine-grained, which kind of makes it difficult to follow through a complex function. I think it would be better, and only experience will prove if I'm right or wrong, that people will want to think about it on a more of a higher level. Like, does this function follow all the rules, as opposed to does just this variable follow the rules? I'd like to give this scheme a try. I think it's simpler. I think it's easier to understand. I think it makes it easy to force people to just mark a function as at live rather than going through and marking each of the variables you want at live to be tracked. I think it's easier just to put it on for the function, and then the whole function is checked. If you want to divide a function up between at live and non-at live things, I would recommend that the best way to go about is to divide it into two functions. One that does the ownership borrowing stuff, and the other that where you get the ownership borrowing stuff. It's a bit like making functional programming. Functional programming works on a function by function basis, not on pieces of a function. It doesn't work on a variable by variable basis. It works on a function by function basis. So, and that seems to work out fine. And I guess we'll see who's right about this. I want to give this one a try first because I intuitively think that this is going to work out better.
I have another question here from Steve. No throw functions can still throw and catch exceptions as long as they don't escape. Is that allowed in at live?
No, it is not. For reasons mentioned in one of the slides in there that might have gone by rather quickly. But the problem with exceptions and exception unwinding is there are too many control flow paths. And the data flow analysis just becomes buried in, shall we say, noise. So what happens when you're doing optimization, when you're faced with exceptions or exception unwinding, is the optimizer, the data flow analysis, just throws up its hand when this happens. And I was kind of wondering, was I missing something? And then I heard a lecture by Chandler Carruth, who was talking about the internals of LLVM, and he said exactly the same thing. If you are unwinding exceptions or have exceptions in your code, the optimizer throws in the towel on that part of the code. Unfortunately, with @live functions, the compiler can't throw in the towel. It's got to check it or not check it. And so what happens is if there's RAII or exception unwinding is possible to happen, or throwing or catching exceptions, the compiler just simply doesn't allow it. You can't use that exceptions in @live functions. This is kind of part of the basis for, I've made a couple proposals for D to make no throw the default. And I think the exceptions may not have been, they seemed like a great idea when I started these. C++ had popularized them, Java had popularized exceptions. And over time, I've gradually come to the conclusion that exceptions really aren't the best way to handle errors. The idea that you're only paying for a feature if you're using it doesn't work with exceptions. Exceptions you pay whether you use them or not. So that's increasingly kind of led me to move away from relying on exceptions for dealing with errors. And I'm looking into the other methods of doing it, like option types and other things. So in @live functions, you can't do exception handling. Well, that's just the way it's going to be.
But Simon asks, assuming DFA becomes a staple in D for ownership, would you deem it worthwhile to guard against null or to implement non-nullable class refs with static checks?
Oh, that is a great question. I don't have a good answer for that. It would require a different kind of data flow analysis than is done as @live. So it would have to be a separate code to make that work. But also, I think null checking, in order to be effective, is going to have to be across functions. And you can't just do it within a function. It's pretty rare that you set a function to, or a pointer to null and then dereference in that same function. Usually the null is part of a data structure or something like that, which starts becoming difficult to do. Data flow analysis is less effective with a complex data structure. So I guess the shorter answer I'm going to say is I've done no plans for that at the moment.
Okay, well, I guess very quickly, Walter, yes or no, when will Phobos, or I'm sorry, that's not a yes, no, it's not. When will Phobos use @live?
Wow, I hadn't really thought about that, but there is talk about making a Phobos too, and it would be something for that, really.
Okay, Walter, I want to thank you very much for donating your time to us here, and now you're free to take off and participate as a viewer.
All right. Well, I look forward to giving Ali some hell here.
Yeah, until it's time for your Ask Us Anything. Don't forget about that. That's coming up at in a few hours here. So
okay, I'll be back.
yeah, 1800 UTC. All right. And I have a winner of the DConf Online 2020 coffee mug.